12 spheres of the same size are made from melting a solid cylinder of 16 cm diameter and 2 cm height. What is the diameter of each sphere? So this whole solid cylinder is melted and is converted to 12 spheres. So I can say that the volume of 12 spheres is equal to the volume of the cylinder, isn't it? Now, as the spheres are of same size, I can say the volume of 12 spheres is equal to 12 times the volume of one sphere. So 12 times, what is the volume of a sphere? Well, that's 4 by 3 pi r cube. This is equal to the volume of the cylinder. Well, what's the volume of the cylinder? Well, that is pi r square h. Now, this r is basically the radius of the cylinder, right? So pi gets cancelled out. We have 12 into 4 by 3 r cube is equals to, actually we have to find out this r, and then we can calculate the diameter of the sphere. So anyway, let's go ahead. So we have r square h of the cylinder. Well, what is the radius of the cylinder? Well, the diameter of the cylinder is 16 centimeters, so the radius is half of 16, that's 8. So r square will be 8 times 8 times the height is 2 centimeters, so 2. So I can write r cube is equals to 8 times 2 divided by 4 times 12, and this 3. Okay, 3 times 4 is 12, and I have 4 times 2 as 8, and again 4 times 2 as 8. So I have r cube is equals to 2 times 2 times 2, that's 2 cube. So therefore r is equals to 2 centimeter. Now the radius is 2 centimeter. We have been asked what is the diameter. Well, the diameter is twice the radius, so diameter is equals to 2 times 2, that's 4 centimeter. So option D is the correct answer. A solid metallic spherical ball of diameter 6 centimeter is melted and recast into a cone with a diameter of base as 12 centimeter. What is the height of the cone? As this metallic spherical ball is melted and recast into a cone, I can say that the volume of the spherical ball is equals to the volume of the cone. So what is the volume of the sphere? Well, that's 4 by 3 pi r cube. And what is the volume of the cone? Well, that's 1/3 pi r square h. This r and this r is different. Okay, so this 3 and 3 gets cancelled out. What I have is 4 times pi times what is the radius of the spherical ball? Well, the diameter is 6, so the radius will be half of 6, and that's 3. So r cube will be 3 times 3 times 3. Okay, this is equal to, we have pi r square. Well, this r is the radius of the base of the cone. So the diameter of the base of the cone is 12 centimeter. The radius will be half of 12, that is 6. So times 6 square, that's 6 times 6 times h is what we have to find. Now this pi we forgot to cancel, so let's cancel it. So I have 4 times 3 times 3 times 3 divided by 6 times 6 is equals to h, right? 3 times 2 is 6, again 3 times 2 is 6. 2 times 2 is 4, so both of these 2 gets cancelled out with this 4. So h is equals to 3 centimeter, right? This 3. So we have found out the height of this cone, and that is option B, 3 centimeters. A metallic hemisphere is melted and recast in the shape of a cone with the same base radius as that of the hemisphere. If h is the height of the cone, then pick up one of the correct options. Okay, so this metallic hemisphere is melted and recast into a cone. So I can say that volume of this hemisphere is equals to volume of this cone. Well, what is the volume of a hemisphere? That's 2 by 3 pi r cube. This is equals to, what is the volume of a cone? Well, that's 1 by 3 pi r square h. Right. Now we have been given that the base of the cone is same as the base of the hemisphere. That is, the radius of the hemisphere and the base of the cone is same. So we can consider this r and this r as equal. Okay, so this 3 and this 3 goes out. This pi and this pi cancels out. This r square and r square of the r cube cancels out. So we have 2r is equals to h. There you go. You found out the relation between r and h. And that is in option A. A hemisphere and a cone have equal bases. If their heights are also equal, then what will be the ratio of their curved surfaces? Now, it has been given that the hemisphere and the cone have equal bases. What does that mean? Well, it means that both of their radii are equal. Right? Now, we have been also given that their heights are equal. And what is asked? We have been asked the ratio of the curved surfaces of the hemisphere and the cone. Let us write it. Curved surface area of the hemisphere upon curved surface area of the cone. That is equal to, what is the curved surface area of a hemisphere? Well, that is 2 pi r square. Now the curved surface area of a cone will be equal to pi r l, right? So r is same, so this r and one of this r's gets cancelled out. This pi and this pi get cancelled out. So we have 2r by l, right? Now we have to calculate l. Well, l is equals to under root of r square plus h square, right? But what is h? Well, we have been given that the height of the cone is equal to the height of the hemisphere. Well, the height of the hemisphere is basically its radius, isn't it? So I can say that this is equal to r square plus r square, right? So L is equals to under root of 2r square, and that is root 2r. Let's put the value here. So we have 2r upon root 2r. This r and this r gets cancelled out. We have 2 by root 2. 2 can be written as root 2 times root 2, right? Divided by, we have root 2. This root 2 and this root 2 cancels out. We have root 2 by 1. So the ratio of their curved surfaces is root 2 is to 1. So option D is the correct answer.